Welcome back. We are now to introduce a topic that is called solving polynomial equations in factor form. This is one of the different ways that we have to solve a polynomial equation. Now, to solve a polynomial equation in factor form, what we need to do is know the factors of a polynomial. Okay? Polynomial in factor form means the following. We're going to have a polynomial that is going to be written as the multiplication of several factors. In other words, I can have something like this: x plus 1, x minus 1, and x plus 2, and all of this has to be equal to 0. This is what we call a polynomial equation in factor form. To solve this type of equation, what we do is we apply the zero product property. The zero product property allows me to do the following thing. It tells me that if I have a product of two real expressions and that product is equal to 0, it means that A can be 0 or B can be equal to 0. So when I apply these two elements, okay, the factor form and the zero product property, then I can solve a polynomial equation. Okay, let's do one example. Example number 1. Let's solve the equation x plus 4 times x minus 8 and all this equal to 0. Okay? So as we see, what we have in here is a polynomial that is written as the product of two factors. Since it is written like the product of two factors, then the zero product property allows me to separate these factors and make them equal to 0, each one of them. So what we're going to have in here is the following: x plus 4 equal to 0, or x minus 8 equal to 0. Once I separate both of them, what continues is you have to solve independently each of the linear expressions that you have in here. So basically what I have in here is x equals 0 minus 4, remember, doing the inverse on the other side of the equation, and therefore we have the first answer, which will be x equals negative 4. Then on the other side, we are going to have x equals 0 plus 8, and therefore x will be equal to positive 8. Now, when you bring these two elements in here and check the procedure, you will see that the equation is equal to 0, and therefore, since we have more than one answer, what we write is a solution set. A solution set that is going to be the two answers that we have in here, negative 4 and positive 8. Okay? For convenience, always write them from the least to the greatest when you write set notations. Okay? There you have an example of an equation that is solved using the zero product property and that was written originally in factor form. Let's continue doing more examples. Now let's analyze example number 2. Example number 2 tells me to solve the equation (3x minus 1) 2x plus 7, and finally x minus 6, all this equal to 0. when you have this number of factors, what you identify immediately is the number of possible answers that you're going to have with your equation. Since in here I have 3 factors, then my polynomial equation is going to have 3 solutions to the problem. So we start by solving independently each one of them. So 3x minus 1 equals 0, 2x plus 7 equals 0, or x minus 6 equals 0, and we go downward with each one of them. In here, we're going to have 3x equals 0 plus 1, and finally, we're going to have 3x equals 1, and this 3 that is multiplying in here goes dividing to the other side, so finally your answer will be 1/3. We have the first solution. Then let's take the second one. The second one will be 2x equals 0 minus 7. Therefore, you're going to have 2x equals negative 7. And this 2 that is multiplying goes dividing to the other side. So, x becomes negative 7/2. Okay? We have the second answer. And finally, we have the third factor, which is going to be x equals 0 plus 6, and finally x equals 6. So once you have identified your 3 possible solutions, then you proceed to write your solution set. Okay? Let's remember, let's put it in order. In this case, we have a negative number, so solution set will be negative 7/2, positive 1/3, and finally positive 6. And there we have the 3 solutions to example number 2. Okay? Now, let's analyze example number 3 because this one becomes a very special situation. Example number 3 involves a power. Okay? So let's analyze what is going to happen. We're going to have solve the equation (2x plus 9 to the second power equal to 0. Now, when we have an equation that contains a power, basically what we have is a repeated factor. The repeated factor will be 2x plus 9. That means that 2x plus 9 will be repeated 2 times in here. It is not necessary that you write that 2 times because you're always going to work with the same factor. So in this case, when you have powers in the polynomial equation, just take this once and solve for that element. So 2x plus 9 equals 0. Then 2x equals 0 minus 9. 2x equals negative 9. And x equals finally negative 9/2. Because this 2 goes dividing to the other side. With the final observation that this negative 9/2 will be considered what we call a double root, because it will be repeated 2 times. And if we have more roots, then they will receive names like triple root, multiple root, etc., depending on how many times the power is repeated in each of the equations. Okay? Basically here we have the different types of exercises that we can have in this one, and we're going to do one more to finish up today's session. Okay? The last one includes the possibility of having many factors. And by many factors we mean different types of roots in their solution. This is the case. Example number 4. Solve the equation x minus 1 to the third power times 4x minus 3 to the fourth power and we have one that is a single root, which is going to be x plus 7. Now, if you consider that situation that we have in here, what we have is physically 3 factors. But in general, what we have is 3 factors that are x minus 1, 4 factors that are 4x minus 3, and 1 factor that is x plus 7. So this polynomial equation has 8 possible solutions. 3, 4, and 1. With the advantage that some of them are going to be repeated and this one that is going to be single. So we're going to solve them by separate, and remembering that we only need to copy it once. So here we have 4x minus 3 equals 0, or x plus 7 equals 0. And in here then we go solving each one of them. This one will become x0 plus 1. Remember doing the inverse operation on the other side of the equation. Therefore we have x equals positive 1. Then we solve this one for x equals 0 plus 3. Then for x equals positive 3. And finally x equals 3 over 4. So we identified the second solution. And in here we're going to have x equals 0 minus 7, x equals negative 7, and here we identify the third group. Okay? What are we going to have in here when we write the solution set? When we write the solution set, we indicate the type of roots that we have. Positive 1. Oh no, let's start by negative 7. So negative 7, which is the smallest value. Then we copy 3/4, and to 3/4 we're going to add, since we have 4th power, we're going to add the initials MR, which means multiple root. And this one, which is positive 1, we're going to add the initials TR, which is triple root. Triple root because we have it repeated 3 times. So in this case, this is the final solution to this polynomial equation that is written in factor form. Hope that all this procedure was clear to you. See you on my next section.